Welcome to YouTube channel scientific underscore math. Finding inverse of a matrix with LU decomposition method and the Gauss-Jordan elimination method. In earlier lecture, we have already studied how to find the inverse of a matrix using the LU decomposition method, and we have also write a MATLAB code for finding the inverse of a matrix using the LU decomposition method. I will provide the link in video description of both these lectures you can watch. And in this lecture, we will learn a Gauss-Jordan elimination method to find the inverse of a matrix, how we can find the inverse of a matrix using the Gauss and Jordan elimination method. And in the next lecture we will write MATLAB code for this one. Okay, so let's start today lecture. And okay, so for finding the inverse of a square matrix of order n cross n, that is the matrix A, the Gauss-Jordan method is can be easily modified. Okay, in early lecture we have studied the Gauss-Jordan method. What is Gauss-Jordan method? And we have also solved example related to the Gauss-Jordan method. I will provide the link in video description of Gauss-Jordan method to solve this system of linear equation. Okay, you can watch. But in this lecture, we will find the inverse of a matrix using the Gauss-Jordan elimination method. Okay, so how we can find the inverse using the Gauss-Jordan, and this is achieved by first attaching to A itself an identity matrix. First, we attach an identity matrix to the matrix A of the same size as the matrix A. Okay, so in figure A, we can see that this is the figure A, and we have the this one is the matrix A, and this one is the matrix identity matrix. Okay, so after attaching the matrix identity matrix with the matrix A, we have this one is the augmented matrix. Okay, so this is depicted schematically for a 3 cross 3 order matrix, and the Gauss-Jordan process is then used to transform the elements of the matrix. Okay, so we apply the Gauss-Jordan method on this left side of the augmented matrix, and to ones along the diagonal, we will make all the elements ones along the diagonal, and zeros off diagonal using the Gauss-Jordan procedure. Okay, so the term of the identity matrix in the figure A, we can see that the right half of the Granic matrix are transformed during this process. This will be the this will be transformed. Okay, so resulting in the elements A dash like that. Okay, in figure B we can see that the left half is transformed into the identity matrix, and the right half is transformed into the inverse like that, the matrix A prime. Okay, so which are the inverse of the matrix A? Okay, so this is a very simple to find the inverse of a matrix using the Gauss-Jordan elimination method, and let's solve the example related to this one. Okay, so we have matrix A of order 3 cross 3, and we will take of same identity matrix of same order that the matrix A have, like we have the identity matrix also of 3 cross 3 order. Okay, so now we write the augmented matrix like that. We attach the identity matrix to the matrix A, and then we have this one is the augmented matrix. Augmented matrix. Okay, so now we apply the Gauss-Jordan procedure to transform this one to identity matrix, and this will be the inverse of the matrix. Okay, so first we make the pivot element 1, and then we will make off diagonal elements 0 and 0, these two elements. Okay, so how we can normalize, how we can make these two the element to 1. Okay, we know that what is normalization in earlier lecture, in the lecture of Gauss-Jordan elimination procedure. We studied in detail normalization. You can watch lecture. I will provide the link in video description of normalizing. Okay, so first we divide the pivot row 1 with the pivot element 2 to normalize. the pivot row. So we have this one is the pivot row. We will divide this 2 by 2 to normalize this one. Okay. So after dividing and we have this one, we can see that this now this one is uh, one normalized. Okay. So now we will eliminate this term that is below the pivot element. Okay. So multiply row 1 with this term and subtract from the row 2. Okay. So we will subtract from this one is the R2 and this one is the R1. Okay. So after this one, we can see that this is 0 and similarly we will make also a 0 this term. Now again multiplying the row 1 with 1 and subtract from R3. This one is R3 and this one is R1. Okay, so now we can see that these two terms are now 0 and 0, or that are the off diagonal terms. Okay, next we have this pivot equation or pivot row. Now we will make one this element, the pivot element, how we can make one. So we will divide this 5 by 2 row 2 with the pivot element. For example, means 5 by 2, this will we will divide by uh, 5 by 2, and this will be 5 by 2 and multiply 2 by 5, and this will cut or cancel this one, and this will be 1. Okay, so to normalize the pivot equation, and after this one we have the pivot element is 1. Okay, now we will eliminate these two off diagonal terms. Okay, so multiply the row 2. Okay, so with 0.5 and subtract from R1. First we will make a 0 this one, and then we make 0 this one. Okay, so here we can see that this is now 0 of diagonal element. Next we will make 0 this term, and again we multiplying 0 2 with 0.5 and then subtract from R3. Okay, so our diagonal terms are now 0, and after this one, now we have a new pivot equation or the pivot row, that is this one. This one is the pivot row. Okay, now we will make this one again by dividing the 22.5 by 22.5, and this will become 22 by 5 multiply 5 by 22. Okay, so this will cancel out and this will be 1. Okay, so first we normalize this row, and after normalizing we have the pivot element is 1, and now we will make 0 of diagonal elements, these two terms. Okay, so here we can see that this is 0, and next we will make 0 this one. Okay, so now we can see that here we have on the right side of the augmented matrix, we have the identity matrix. On right side of the half right side of this one is the inverse of the matrix A, and this one is the inverse of our matrix A. Okay, so this is the way how we can find the inverse of a matrix using the Gauss Jordan elimination method. And in next lecture we will write a MATLAB code for finding the inverse of a matrix using the Gauss Jordan elimination method. Okay, so thank you so much for watching my video. Please subscribe my channel scientific underscore math.